We do have a little bit of review of our nice words, math words. Sum, of course, means we're adding, so make sure you remember that. Difference, subtracting, product, we're multiplying, and quotient, we're dividing. When we're talking about the domain, a sum, a difference, and a product all have the same domain. The domain for the outcome, the actual sum, difference, or product, has to be this little U shape we've looked at before. It means the intersection. So it has to be in both. The answer has to be in both the domain of f of x and the domain of g of x. So when you see that, that's what that means. It means that it's in the domain of f and the domain of g. It has to be in both. And that's the same for a difference and a product. For a quotient, it is a little bit different. And what this means here is it's the set of all the x's. So we have a brace for set and all the x's such that, or where sometimes, f of x intersects g of x. So it's the intersection just like above. So it's the set of all the points that have to be in both f and g where, so there's some restrictions on that. Just because you're in f and g, you couldn't be, you could not be an answer. And it would be any number that would make the bottom equal 0, the bottom function. And if you remember from Algebra 1, we call those domain restrictions. Again, some theory here, so don't get too stressed. Let's look at some actual applications. On this one, we want to actually add some values. So at 0, it's pretty easy. We can actually identify. Our graphs are a little sketchy here. So we're just going to kind of guess some points. But here we know at 0, 2 plus 3, because they want us to add the two graphs. 2 plus 3 is 5, so it will make a new point up here. And I'm just going to pick some x values here. So this is a little better than 2.5. And a little less than 3.5. So 2.5 and 3.5 would make 7. No, 2.5 and 3.5 would make 6. Let's try getting that. There you go. And I'm just going to pick another point on the other side. And so again, this is real close to 2.5. Now we're up to almost 4, not quite. So 4 and 2.5 would make 6.5. So it'll be almost up at 6.5. And then, as we pick another point as it goes along, what I'm trying to do is hit approximately where x is 1, x is 2, x is 3. Those grids are just not real clear on my graph or your graph. So if I have this point over here, this is right about 2, and this is now up a little more than 4. So I'll be slightly above 6. Right? And we'll maybe hit for this low point here. That one is down almost to 1, and this is still climbing a little bit, so that's up maybe 4.5. 4.5 and 1 make 5.5, so it still drops the graph a little bit. And then it's going to turn back and go up a little bit, not a whole lot. We're about 1.5 and 4.5, so 5, 6. Climb back up a little bit. So our sum of these two would look something like that. Again, that concept is what we were doing in yesterday's the graphical video. So looking at some algebraic problems, this is the new stuff for today. They're going to actually give us the algebraic expression for that function. To do these, all we're doing is replacing f of x with its actual expression, 3x plus 5. And I'm going to add to that g of x expression, 3x squared plus x minus 4. Notice I'm emphasizing expression. There is no equation really here. We can substitute and find values, but we're not looking at an equation specifically at the moment. Right, so looking at this then, we're just combining like terms. So that's 3x squared plus 4x plus 1. That's our sum of those two functions. So for the next one, we want to subtract. It's a difference, and I believe yours has f of x minus g of x. So we'll do that expression. F of x is 3x plus 5 still, and you're subtracting the g expression, the 3x squared plus x minus 4. That's what you're subtracting. The first thing you want to do is go through and distribute that negative. So I'm going to have a negative 3x squared, a negative x, and a positive 4. Those are going to go together with my 3x plus 5. And again, I'm just combining like terms. So I only have the one squared term, negative 3x squared. I've got 2x terms, so plus 2x, and 2 number terms, plus 9. So that's what I should be getting on the difference. On the product, we literally are going to do 3x plus 5 times 3x squared plus x minus 4. Let's try to write that correctly. And all you're doing here is distributing. So that 3x multiplies times each of the 3 terms. So that's going to be 9x cubed plus 3x squared minus 12x. When I come and distribute the 5, I'm going to multiply just like before, so that's 15x squared. I'm going to line that up underneath my x squared term. So 15x squared here. That'll be plus 5x and minus 20. If you line up your terms, then you're set. Your like terms are already together. So I just get 9x cubed plus 18x squared minus 7x minus 20. That's what the product is going to look like. We're going to skip on to a fraction here. Fraction, remember, is division, so these are quotients. And literally, you are just writing 3x plus 5 over 3x squared plus x minus 4. The only thing is, you do have to list domain restrictions with fractions. Anytime there's a variable in the denominator, then you've got to tell what that variable can't equal, because there are going to be things the variable would be, there's going to be values of the variable that would cause the bottom to be 0. So what I want to know, my domain restrictions are going to be where 3x squared plus x minus 4 equals 0. This is just finding the solutions to this quadratic equation. So first thing you would want to try is factoring. This one will factor. Plus 4 minus 1. So since I want to know where it equals 0, I set each piece equal to 0. And I will get x would equal negative 4 thirds. X is a little weird looking there. And x would equal 1. Technically, these are restrictions. So this, you're telling what x can't equal. So its domain restrictions would be x can't equal negative 4 thirds and x can't equal 1. If we did the same on g of x over f of x, it's a little bit nicer because we get 3x squared plus x minus 4 on the top, and in the numerator we just have that 3x plus 5. So our restrictions are going to be 3x plus 5 can't equal 0. So x can't equal negative 5 thirds. This is my only domain restriction. You can have more than one. Alright, so if you'll flip the page, we're going to start with, look at a little bit of function composition. This is what we were doing yesterday, where you're taking one function, finding a value, replace that value into the second function. So we have f of g of x. That is not a minus, that is like, this is what it reads, how it reads, f of g of x. Alright? And the blanks that you have, remember, you can start on the inside is where you want to start, and then you work your way out. Right? We also pointed out in yesterday's video, when you see this parentheses like that, this is not multiplication. No multiplication. You have to have a solid dot before you're talking about multiplication. And as far as the composition, we'll come back to that. Let's go ahead and take a look at the problems. These are like we were doing yesterday in the video. The number that they give you is the x value. So I want to know when x is 2, this is your x, what is the value of the function g? Well, here's 2, and your function actually sits right there at that point. So that means g of 2 is a 0. So now that goes in and inside function f. I want to know when x is 0, what is function f? Well, x is 0. It's right here, and the black function is f, and it happens to go through that point, so I get a 0. All right? Doing the same thing here. When x is 0, what is function g? Well, you're up here now, so it's 4. This value is 4. And so x now at 4, what is the black f of x function? And it's here, so we'll read over. It looks like that's a 2. All right, I'll let you try a couple more. Let me give you the values, and you can stop and see what you got. I got another 2. I got 0, 4, and 1. All right, if you aren't getting those, then make a note and ask me about them in class. All right, next thing, we're just doing some composition with functions. What that looks like when they say g of x is going to go inside of f of x, they mean literally this 2/3 x is what you're replacing into your f. So f of 2/3 x. This, all of it, not just the x, becomes the x in your f of x equation. So that's -3. When I get to the x, I write the whole expression, 2/3 x plus 5. Well, that's over 1. The 3's can cancel, so I get a -2x plus 5. And that's my expression. Doing the same thing here, except they gave me a number. When they give you a number, you want to just step to the side and figure out what g of 3 is. Just like we would have looked that up on the graph a minute ago. And g is that 2/3 x, or x is supposed to be a 3, so that gives me a value of 2. This comes back up in place of g of x. So I get f of 2. Maybe I should have that come here. That's going right here. Right? And now I'm plugging 2 into my f of x equation. And that equation is just -3 times the x, which is 2, plus 5. And so that winds up being -6 plus 5, or I get a -1. That's my final answer. Right? Take a look at a couple more. 4x replaces g of x. So I'm looking at f of 4x. 4x replaces the x in the f equation. So I get 2 times 4x, all of that squared, because x is being squared and this replaces x, minus 3. So that's 2 times, that value squared is 16x squared, minus 3. And then I have to multiply by 2, so I get 32x squared, minus 3. This whole value, or expression, is your answer. On the bottom one, first thing I'm going to do is rewrite that to be g of f of 2. And since they gave me a number, I'm going to figure out what f of 2 is by plugging that in. So that winds up being 2 times 2 squared minus 3. So I wind up getting 2 times 4 minus 3, which is 8 minus 3, or 5. That value comes over here into my g equation. I want g of 5. Well, g is just 4 times x. My x is now 5, so I get 20. Last one we're going to take a look at on here, you're going to have f of negative 2. So again, I'm going to plug negative 2 in to f. I will simply do that. That winds up being 2 times negative 2 squared minus 3. And that negative 2 has to be squared first. So that's 2 times 4 minus 3. 8 minus 3 is 5. That comes up into the outside equation, which is also an f. So I'm going to have 2 times 5 squared minus 3, which is 2 times 25, which is 50 minus 3, which is 47.